Okay, so the thing I was trying to say is actually if the load factor is greater than 0.5, there can be a case that you can never end up finding any empty space. Let's have a look. So let's say if 58 comes, so it will be inserted in 8, right? Then let's say another number, 68. If 68 comes, it should be inserted where? It should be inserted here, right? So 68. Then another number can be anything actually. Let's say another number can be 22. So it should be inserted here, right? Then another number can be 57. So it should be inserted here. Then another number can be 44. Okay, so 44. Let's assume that it is inserted here. Now let's try to insert another number. 77, 78, let's say. If I want to insert 78, first of all, what's happening? So 78 plus 0 modulo 10 is 8. So it's not working. Okay. 78 plus 1 modulo 10 is 9. It's already occupied. 78 plus 2 square modulo 10. Okay. What is it? So 78 plus 2 square modulo 10 is, I think, 2, because it's 82, right? It's already occupied. Okay, so you take 3 square. So it is what? 87. So 7, but 7 is already occupied. You try 4 square. So what will happen? It will be, I think, 16. So 94, right? Yes, 94. So if there will be 4, the remainder will be 4. 4 is already occupied. You take 5 square. So I'm just adding with 78, right? So I'm adding 5 square. So when I add 5 square, the remainder is 3. Okay. So now you have got value. Okay. So you take 78 here. Okay. Now actually, if I insert 88 here now, what will happen? So for 0, there will be, for 0 will map to 8. It will not work. 1 will map to 9. It's ordered by 2 will map to 2. It is already occupied. 3 square will map to 7. Occupied. 4 square will map to 4. Occupied. 5 square will map to 3. It's now occupied. 6 square. Where is it mapping? 6 square it will map you to 4. Then occupied. 7 square is mapping you to 7. It's occupied. 8 square is mapping you to 2. It's also occupied. 9 square. So you just make the calculation. I just did it in my free time. You can do it also. So 10 square is mapping to 8, occupied. 11 square is mapping to 9. It's already occupied. 12 square to 2. 13 square to 7. Okay. So this problem occurred, and actually it will never reach to any solution. Okay. So if you are lucky, you are inserting 11, it will be inserted. But I said that there can be a case. So there you might fail to find a free slot. So this is another problem. Okay. So that's why actually you have to keep the load factor less. I unintentionally gave this example I didn't check the output. Then some of the students fall into this loop. So some of them tried 3 or 5, even 7, 8 times, but they couldn't come up with the solution. And I also did a bad thing. Somehow in that exam, I told them that some of them didn't sit with the calculator. So that was the very early exams of data structure. So what happened is it was a 4-digit number. So it was very time consuming for them to calculate the remainder. Okay. So some of them actually wasted a lot of time for this. I gave marks, but it was unfortunate. I didn't notice it, but it can happen. Yeah, 42, yes.
Oh, sir, should you stop when you meet again remainder? Because you can see we met 7 and 7, but in the other one we never met.
Yes, you can actually there you can stop at some time. Okay, so maybe after 4 or 5 trials, even if you cannot find it. Okay, but actually we don't continue checking like this. Rather than that, when the load factor is greater or equal to 0.5, actually we shift the whole table into a new table. Okay. So
okay, sir. In that case, you can only use half of the size.
Right. can only use half of the size. Okay. So half of the size. I mean, if you are unlucky, in that case, only half of the size. So we, as programmers, we always have to think about the worst case, right? So here, actually, if 10 comes, you can insert it here. If 11 comes here, 25 here, right? So it can be used, but for some test cases, it will not work. Yes, 19.
Sir, I just now searched the internet and found that the number having 2, 3, 7, 8 at the units place can never be perfect square. That means if I have a number 10 plus, and if I have occupied all the numbers other than 2, 3, 7, 8, then it won't be a there will be a collision.
And actually, I will keep on rotating in this.
Yes, sir. There will be infinite loop. Yes.
What are the numbers?
2, 3, 7, 8.
Okay, so you are saying, so it's like if I so can you state it again?
That means no square numbers ends in 2, 3, 7, 8. That means the units place of a square number can never be 2, 3, 7, 8.
Actually, it doesn't matter because if we manipulate the previous our starting position, we can place keys on those positions too. Because in this test case, we have filled all those 2, 3, 7, 8.
Yes. Yes. So the point I was trying to make, I think it's clear to all of you that if you do it like that, I mean, so this is one of the drawback of quadratic probing. Okay. So this is a thing, and although it is not actually giving you any cluster, although it's not actually giving you any direct cluster, but it's kind of an indirect cluster. Why do I say like that? Because if I, so even for, so when 58 comes, I know that first of all it has to check 8, then it has to check 9, then it has to check what? Then it has to check 2, right? After that, so if 68 comes, I already know that these 3 locations are filled. However, still I have to check these 3 values and then add a location that will become for I equal to 3, right? So although it is not a visible cluster, however, it's acting like a cluster, right? So it's called a secondary cluster. Okay, so the problem of quadratic probing is it suffers from the secondary cluster problem. And what is it? Actually, secondary cluster means although you are increasing the values of 1, 2, or 3, actually, if it ends up with the same number, actually you have to go through the same procedure again and again, and it will add after the cluster. So, and then what will happen? If you get a number after I equal to 3 and insert it, if another number comes with 8 at the end, it will again go through 1, 2, 3, and then the solution will come for 4 if it exists. So although it's not directly a cluster, but it's working like one. It's called secondary cluster problem. Okay, but it is solving the primary clustering problem. But however, that is another issue. And before taking the question, when actually this sort of clustering issue occurs, so if lambda is greater than 0.5, what should you do actually? You know that there can be a case for where there will be infinite number of collisions. So you can do, there's another idea called rehashing. I mean, rehashing is the formal term. I have already said what it is. Rehashing means actually the practice is you take a size you take a hash table of size 2 times the current one. So if there will be a collision, load factor greater than 0.5, the idea is I will take a table size of 20 and then copy everything there using a new hash function. Okay, so I should rather say that rehashing, one of the ideas of doing rehashing is to take hash table of 2 times the table size and insert everything there using a new hash function. Okay, so a new hash function might distribute it better. Okay, function function, but you can also use the previous one, no problem. But it should be able to distribute them properly. Now, about rehashing, you can say that, sir, one problem is actually when after inserting 50% of the values, I have to when I insert everything in the new using the new hash function in the new table, I have to go through order of n operation, right? So if there are n numbers, I have to copy them, right? So it was never supposed to happen for hashing, right? So one thing is actually you can take always a very big hash table. That's one of the approach. And another thing is actually I saw it in the MIT lecture that I suggested one day. So they said that actually in every data structure, in the built-in data structure, they first of all they take an approximate maybe 128 or let's say 1024 size hash map. However, it can run out of memory, right? So when it can sense that okay, the lambda is getting very close to 0.5. After every insertion, it tries to copy some of the elements into a new position. Okay, so actually it doesn't wait for the overall table to be 0.5 load factor. Rather than that, maybe when it is getting closer to load factor, for every insertion, it copies a few items to the new hash table. So when it finally reaches 0.5, I can just move to the new hash table without spending much time for that. Okay, so it just distributes the copy procedure for different insertions. So it is one of the optimization idea, and it's a research problem. Okay, so how can you efficiently copy it from here to there? Okay, so there can be different approaches of moving the items there, because when 0.5 occurs, if there are 1 million numbers, so it will take a lot of time to copy all of them, right? But they optimize it somehow so that this order of n never actually happens. Okay, but of course the programming languages do not take a very large hash table in the beginning, so it's a very bad idea. But also they optimize the copy. Questions?
Sir, I don't understand that to find the location of inserting, why do we have to repeat the procedure again and again starting from 0? I mean, if there is collision up to 4, it should be for like every cases that, I mean, we are adding the same values.
The problem is here the code, let's say I know that the code I is equal to 2. After I equal to 2, I have solved the collision. So this is only true for the remainder 8, right? So if I want to remember that I have to start from I equal to 3, I have to remember the value of I for every row of the hash table. Isn't it like that? So that will be difficult. For 8 I am starting from I have to start from 3, right? But for if another value comes, I have to start from 0. So how do you know that when you start from 1 or when you should start from 3?
Okay, sir.
Okay. Questions? Yes. Any other questions?
Sir, I think there will be a pattern after some iteration. Like for 88, there will be a pattern after I equals to 11.
The pattern means?
So the same value will repeat. Like 9 to 7 will be repeating like the I equal. Yes, sir. If you take I equal to 2, then the value will be 2, and after that, if you take I equal to 12, then it will again repeat like yes, sir.
Okay.
If
So
you
I
take
think the value
I equal to 2, then it will be again 2, and
okay. Okay. I didn't observe that, but there can be cases like that. Okay. So you can also yes.
আমি বলতে চাচ্ছিলাম যে যদি প্যাটার্ন হয়, মানে যদি রিপিটটা কি প্যাটার্নের মধ্যে পড়ে, তখন কি ছেড়ে দিলেই ভালো না, নাকি তার আগেই আমরা ছেড়ে দিব এরকম বলতে?
Actually you can wait until a pattern occurs. It can be one approach, or you can have some resistance that how many times shall I try. Okay, so if
প্রত্যেকটা নাম্বারে 1 থেকে 10 পর্যন্ত স্কয়ার যোগ করার পর একই প্যাটার্ন আবার আসবে। সো 1 থেকে 10 পর্যন্ত যোগ করাই এনাফ।
Okay. So is it true for all cases?
প্রতিটা নাম্বারের জন্য এটা ট্রু। যেমন 88 এর জন্য 11 থেকে একটা নতুন প্যাটার্ন আসতেছে, 89 এর জন্য আবার 11 থেকে নতুন প্যাটার্নটা আসছে।
11 থেকে তো আসলে লাস্টের ডিজিটটাই শুধু স্কোয়ার হচ্ছে, সো লাস্টের ডিজিটটা তো আমরা অলরেডি মানে 10 এর থেকে আমরা লাস্টের ডিজিটটা আমরা অলরেডি ক্যালকুলেট করে ফেলেছি।
Okay. So actually, so you are saying that for any number, squaring from 1 square up to 10 square, it is enough. Then again from 11 square, a new pattern. So the same pattern repeats, right?
1 to 10 অথবা 0 to 9 যে কোনো একটা করলেই হবে।
বুঝতে পেরেছি। হ্যাঁ, it's a very good observation. আচ্ছা, ঠিক আছে, একটু চমৎকার কথা বলছেন। Nice. Thank you. Anything else to add? এটা আমি লিখে রাখি। Good observation. Okay. Anything else? Okay. আচ্ছা, তোমাদের তো এটা পরে আমার সাথে ল্যাব, তাই না? আর কিছু আছে?
স্যার 2B এর স্যার OP ল্যাব।
OP lab. আচ্ছা, কথা বলি। Okay, তাহলে I am not continuing any further. Actually, I wanted to cover double estimation. It will take 5 minutes. I will discuss it in the next lecture. No problem. Okay. ওটা হচ্ছে ঈদ মোবারকের পরে পড়ানো হবে, ঠিক আছে? So this will be the last lecture before Eid. So have a good Eid.
Eid Mubarak, sir.
Eid Mubarak এর কাজ আছে তো। Okay, let's show the meme for today. আমি meme দেখানোর জন্য নতুন টপিক কভার করলাম। Time for that. So this is the first one. This is also from your batch. Okay, so when the equal value comes, so shall I put it the left or right? So it's a very confusing statement. The next one is from the Euro batch. So the data can be left or right. So they are fighting, then find matches. Okay. So this is the second one. Actually, these things are made by your friends, right? So this is the final one. This is very interesting. Okay, so this was sent long ago, but I didn't get time to show it. It was a very good one. Okay, so let's take the attendance. So it's very important to share this. Okay, that's why we don't have a double check today. On lecture 17. Okay, so let me share. Okay, so in the next 5 minutes, let's take that attendance. Hold on. 1, 2,
On present.
3,
3 present.
4 present.
5 present.
6 present.
7 present.
8 present. 9 present.
10 present.
11 present.
13 present.
14 present. 15 present.
16 present.
17,
17 is present. 18 present.
19 present.
20 present.
21 present.
22 present.
23 present.
5,
24 present.
25 present, sir.
26,
26 present.
27 present. 28 present.
29,
29 present, sir.
30,
30 present, sir.
2, 3,
33 present, sir.
34 present.
5, 6,
36 present.
7,
37 present.
8,
present.
9, 40,
Present.
41, 42, 45, 46,
Yes, sir.
7,
Present, sir.
Okay, so thank you. And ID 1 to 1 to 25, 23. I will take the Viva at 4, and the rest of the student will start now. Check it from the Google Sheet. Okay, so I
Sir.
have update time here. Follow.
ল্যাব আজকে স্যার রিভার্স অর্ডার নেওয়া যায় না
আমি তো টাইম দিয়ে দিয়েছি, কনফিউশন হতে পারে। নেক্সট হ্যাঁ, ঈদের পরের কথা হচ্ছে রিভার্স নেবে যাও। হ্যাঁ, আজকেরটা করে ফেলাম, তাকে আগে দেওয়া উচিত ছিল না হলে। ওকে, কনফিউশন হবে, দিয়ে দিয়েছি তো এটা। ওকে, সো নেক্সট ল্যাব ইট উইল বি রিভার্স অর্ডার। থ্যাংক ইউ সো মাচ। আসসালামু আলাইকুম।
In Mubarak. All right.
Assalamualaikum, sir.
Mubarak and